All right, so I know I say this a lot, but relations and functions, this one is like super interesting, neat, different. I really, really like this one. Students will be able to look at different relations and identify if it is a function or not. So we have inputs and we have outputs. This particular scenario, this first one says, consider the following rectangle. It has a width of 2 units and an unknown length for each of the following lengths units. Calculate the area. Okay, so what we need to remember first is that area is length times width. So in this case, we're saying area is going to be 2 times x. So if the input is 1, we're going to do 2 times 1 and get an output of 2, or an area of 2. If the input is 2, we're going to do 2 times 2, get an area of 4. 2 times 3, get an area of 6. 2 times 4, get an area of 8. So if the input here goes in for x, the output is the area. Try this one with a partner. Well, we're going to do it together. The rectangle below once again has a width of 2 units and an unknown length. This time, complete the mapping diagram by calculating the perimeter. So we need to remember that perimeter of a rectangle is 2 times length plus 2 times width. So for this one, it's going to be 2 times the length 2 plus 2 times the width x, which is the thing we don't know, the input. So we're going to do 2 times 2. Well, we know that's always 4 plus 2x. So here we would do 4 plus 2 times 1, and that's 6. 4 plus 2 times 2. Well, that's 4 plus 4, so that's 8. 4 plus 2 times 3, that'd be 4 plus 6, which is 10. And 2 plus 2 times 4, 4 plus, that would be 4 plus 8, which would be 12. So that's your idea of an input and an output. In this case, we've talked about area of a rectangle, perimeter of a rectangle. Well, what about just general functions that aren't based on geometry? Look at the following mapping diagrams of inputs and outputs. Do you see a pattern? First, determine the rule. How do you get from the input to the output and then complete the missing outputs? So first I'm going to say, is there any pattern going down the output column? 8, 10, 12. Do you guys notice that it's plus 2, plus 2? Well, anytime you've got a pattern going down of repeated addition, that means that your rule where you go across is going to have to do with multiplication. Remember, plus 2 plus 2 plus 2 would be the same as multiplying something by 2. So our rule has to be something to do with times 2. So what if I did 1 times 2, 2 times 2, 3 times 2, 4 times 2? Would that get me the number in the output column? And you're like, no, Mrs. Fraser, 1 times 2 is not 8. I would need another 6. 2 times 2 is 4. No, that's not 10. I would need another 6. 3 times 2 is 6. I would need another 6. So the rule must be that we're multiplying by 2 and then adding the extra 6. So 4 times 2 is 8, plus an extra 6 would be 14. 5 times 2 is 10, plus the extra 6 would be 16. 6 times 2 would be 12, plus the extra 6 would be 18. 7 times 2 would be 14, plus the extra 6 would be 20. So first, by looking down, we can see if there's a pattern to give us that multiplier. Now the second example, I can't use that same strategy, and I can't use it because you'll notice this is 8, 11, 27, where this one was 1, 2, 3, 4. So here, I can't use that as sort of a shortcut. I am, however, going to look at 8 and 3. How do I get from 8 to 3? Well, one way would be to minus 5. 11 to 6. Oh, okay. Well, I could minus 5. Let's see if that continues to work. 20 minus 5 gives me 15. Well, if that pattern works for all 3 that I have, I'm going to continue that pattern. So I'm going to continue 7 minus 5 is 2. 100 minus 5 is 95. 37 minus 5 is 32. And 240 minus 5 would be 235. So what we did was we looked for a pattern first, up and down, and then we looked for a rule which went across. So how do we write the rule? What did we do to the input to get the output? So on the first one, we multiplied by 2, so 2 times the input, and then we added 6 in order to equal the output y. On this one, we just took the input and subtracted 5 in order to get the output y. So the rule is where we write the equation. Now create your own mapping diagram. Identify the rule that works for each pair, fill in the mapping diagram below, but leave the last couple of outputs blank. Challenge a partner to fill in the missing outputs. So I could just come up with one, for example, 1, 0, 2, 7, 3, 14, and then ask you to find the fourth one. So this one, I'm going to use that strategy where I notice that the first column is 1, 2, 3, 4. So I'm going to look for a pattern going down. 0 plus 7, 7 plus 7. So I know my rule has something to do with multiplying by 7. Now I'm going to say, well, does 1 times 7 give me 0? Well, no, 1 times 7 is 7. I would need to take away 7 to get down to 0. Does 2 times 7 give me 7? No. 2 times 7 gives me 14. I would need to take away another 7 to get down to 7. 3 times 7 is 21. I would need to take away 7 to get down to 14. So my rule is going to be multiply by 7, right? The input, the first number times 7, and then I need to take away 7 in order to get down to the output. So the last one that's here, let that focus. I'm going to do 4 times 7, which is 28, take away 7, which would bring me down to 21. I like these. I think these are really neat. It says, by following the arrows, look at the pairs of inputs and outputs below. For each mapping diagram, determine how many output values are assigned to each input. So for example, number 10 is the input. You might get 0 as the output, or you might get 1 because there's an arrow going to 0. There's also an arrow going to 1. If 11 is the input, I have no output. I have no values that start with 11 because it does not have an output. Then I've got 12 has an output of 0. 12 also has an output of 1. 12 also has an output of 3. There's 1, 2, 3 arrows leaving 12. And 13 has an output of 2. Does each input have only one output? Nope. Some of them have 2 or 3. On this one, if 12 is the input, 6 is the output. If 23 is the input, 15 is the output, just following the arrow. If 30 is the input, 20 is the output. And if 48 is the input, 13 is the output. Does each input have only one output? Each input has only one arrow leaving it, so that's a yes. For which of the mapping diagrams would be more difficult to find a missing output? So if I gave you these two patterns and I was like, okay, find the next output, which one would you have a harder time working with? You'd have a much harder time with the first one because there's multiple possible outputs. You'd kind of have to do some guessing, which is never something we want to do in math. This one has a very predictable, each input has exactly one output. The first mapping diagram above shows a relation because it simply pairs inputs with outputs. The inputs and outputs can also be represented by ordered pairs, so I wrote those as we went. The mapping diagram on the right shows a function. A function is a relation that pairs each input with exactly one output. So if I plug in a 12, you know the result is going to be 6. If I plug in 23, you know the output is going to be 15. This one functions well. Over here, if I plug in 12, you don't know if you're going to get 0, 1, or 3 as the output. So determining whether relations are functions in the diagram. Input 12, output 6. Input 23, output 15. So this is the one from the front page. This one, 1, output 15. 2, output 30. 3, output 45. 4, output 60. In the mapping diagram above, each input is paired with exactly one output, so this is a function. That is the key to figuring out whether or not something is a function. Look at the relationship between the inputs and the outputs above. Is each input increases by blank, each output increases by blank. So as each input increases by 1, 2, 3, 4, so this one's going up by 1. Each output is increasing by 15, 30, 45, 60. The output is increasing by 15. So I can do, 1 times 15. Oh, I got 15. 2 times 15. Yep, I got 30. 3 times 15. So this one, the rule, very easy, is just 15 times x equals y. I didn't have to add or subtract anything because the plus 15 plus 15 plus 15 told me my pattern would be a multiplier of 15, and it turned out that that worked all by itself. I then have here an input of -1 could be an output of 2 or 4. An input of 1 could be an output of 7 or 9. Is the relation above a function? Yes or no? And we would say in this case, is each input paired with exactly one output? Trying to get that to focus. So is each input paired with only one output? And we would say no, this one has 2 outputs. So this one we would say no, -1 has 2 outputs, which is enough, but we can say and 1 has 2 outputs. So that is not going to work as a function. Determine whether the following relations are functions. 2 gives me 6, 4 gives me 3, 6 gives me 0, 8 gives me -3. Now I'm not asking you for a rule, I'm just asking whether or not it's a function. So does each input have one output, one output, one output, one output? We would say yes. Each input has exactly one output. It is very predictable. It functions well. Is the relationship at the left a function? Yes or no? So for the input -9, output 0. Great, one output. Input -2, output 5. Great, one output. Input 5, output 10. Great, just one output. Input 12, output 10. Great. Each input has exactly one output. Never said anything about whether or not there could be repeats. So yes, each input has exactly one output. Repeating outputs are fine. So I like to compare this to like a soda machine. If you've ever seen a soda machine where you put in your money and you get a can of soda out, sometimes you see a soda machine that has more than one button for a certain type of soda. So you might have, for example, the Sprite button, which gives you a Sprite. And then you might have an orange soda button that gives you an orange soda. Well, then you might have a Coke button that gives you a Coke and a second Coke button that also gives you a Coke. So even though there's 2 different buttons for Coke, they yield one result, but this button only gives you a Coke. This button only gives you a Coke. So when you're writing your input and output pairs, -9 only has one output. -2 only has one output. 5 only has one output, and 12 only has one output. Repeated outputs are fine. It's just that each input has to have exactly one output.